right, hey guys, welcome to not week 10, but unit 10, Brain and Skull. Congratulations on taking your last lab exam. You guys did wonderful. Wishing you well on the next lecture exam. I know you guys will do great and just as well as you did on the lab exam. In saying that, we're going to move on to this unit. I want to remind you guys that this is not a replacement for your time spent in lecture, lab, and office hours. This is just but a supplement to those areas. If you've been watching these videos for a little while, I say the same thing every single time. Please, with this unit specifically, spend a lot of time in lab, lecture, and office hours. These videos will not even be close to sufficient to help you with that if you don't spend the time there. If you do, they'll be a very great help to remind you of the things that you saw in those three areas and be a supplement to those areas. So, in saying that, we're going to start off with the bones of the skull. So the first bone of the skull is the frontal bone, right? Frontal bone is going to be right on top of the frontal lobe of the brain. We'll go over that later on, but frontal bone, if I inspect, frontal bone. If I examine, this is my frontal bone. Frontal. All right, so from there, we're going to move on to the parietal, and then from you have a right and left parietal lobe, right and left parietal bone. I'm getting the bones and the lobes mixed up, but right, so parietal bone, right, is going to be right on top of your parietal lobe. Parietal bone. So this is what they look like. Parietal. Okay. And then posterior to the parietal, we have the occipital. All right, so make sure you understand the borders for these bones. It's going to get complicated once we're looking at the bones in the anterior, and then we switch to posterior, inferior, lateral, right? Being able to pin the inside of the cranium, right? It's these bones, you need to know the borders of them so you can understand where they start, where they stop, and you can understand what they look like from all the different dimensions and aspects. So this is our occipital bone. Remind yourself of the borders, be very familiar with it. All right, and then from there, we're going to move on to the temporal bone. Right, you have two, right? So only the frontal and the occipital bone don't have, aren't bilateral, but the parietal and the temporal are. So meaning you have a right and a left. Only for the bones of the cranium. All right, so these are the temporal bones. Make sure you're very familiar. All right, so now that we have those, we're gonna move on to the next. We're gonna move on to the anterior of the skull and go over some bones here. So comprising your jaw and your mouth, right? We have the mandible and the maxilla. So mandible, right, is your jaw and comprising the top of your mouth or your top teeth, right? The bones that are connected to your top teeth. Um, you have your maxilla. So mandible, maxilla. Again, remind yourself of the borders of these bones. Mandible, maxilla. Right, and then from there, I want to remind you guys that inside of the nasal cavity, you can still see the maxilla, right, on the inferior aspect of the nasal cavity, right? And similarly with the roof of your mouth, the maxilla is still comprising the anterior portion of the roof of your mouth, right? So the inferior aspect of your nasal cavity, as well as the anterior aspect of the roof of your mouth. And then we're going to move on to this acronym. So the way I like to remember some of the bones on the anterior skull, the acronym my left eye sees. So remind yourself also that the maxilla is comprising the inferior aspect of the orbit as well. So orbit is just this region where your eye is located. So on the inferior aspect of the nasal cavity and the orbit, your maxilla bone is still comprising these two locations. So in saying that, this acronym, I like to use my left eye sees. So maxilla is the first. Maxilla is the first bone of that acronym. And then from maxilla, we go on to lacrimal. So that left, my for maxilla, left for lacrimal, right? The lacrimal bone is very small. Lacrimal. And then I is ethmoid. My left eye, ethmoid. All right, so look at the ethmoid bone. All right, this is the posterior aspect, anterior aspect. Ethmoid bone. All right, it's comprising a significant portion of the nasal cavity. Right, so my left eye, and then in the back, C's or sphenoid. Right, this big wing-shaped bone here. It looks like a butterfly when you're looking at it from the posterior. So my left eye sees, if I just inspect it, this is the sphenoid bone. And remind yourself, right here, there's a region called the hypophyseal fossa, which is where the pituitary gland is going to sit, and it's going to be connected to the infundibulum and the hypothalamus, and we'll go over that later. But we'll go over that later. But I just want to show you the sphenoid bone and just point out a structure that we're going to be looking at shortly. All right. So we went over that. Let me inspect. So we went over those. We just have two other bones to go over inside of the nasal cavity. We have the vomer, and then we also have the inferior nasal concha, or conchae, because there's multiple plural. Inferior nasal conchae. So right and left inferior nasal concha, and these are conchae plural. You add an e. Vomer bone. Okay, right. And remember, the superior aspect of the nasal cavity is still the ethmoid. Right. That's what we were seeing previously. Inferior aspect, you have your vomer, inferior nasal concha, and then also making up the bottom of the nasal cavity, you have the maxilla. Making up the bottom. That platform maxilla. And then we have one other bone that we need to go over, right? Is the palatine bone. All right, so remember we said that the roof of the mouth is comprised of the anterior portion of the roof of the mouth is comprised of the maxilla, but the posterior portion, the hard palate, is comprised of the palatine bone. Palatine bone, right? So, and the palatine bone looks like an L, right? L, L, right? So palatine bone. And then we actually have one last bone that I didn't go over. Just realized. I'm glad I caught it. We have the zygomatic bone. Okay, these are the cheekbones. Zygomatic bone. All right. From there, I want to go into the structure of the ventricles, and then I'm going to bring you to the brain anatomy so we can understand what's going on before we actually look at the brain anatomy. So, because the ventricles are right in the middle of the brain anatomy, and if I just show you the brain anatomy first, you're going to be like, what are you talking about? So I'm going to make sure that I'm going into that first. All right, so the choroid plexus is where cerebrospinal fluid is going to be made, right? And you can see the choroid plexus is majorly inside of the lateral ventricle. You have a large choroid plexus. So I just want to show you how cerebrospinal fluid is being made and where it's actually going, just so you can understand. You don't need to know this, but I just want to give you guys some extra understanding so it can make sense when you're looking at these things in lab. All right, so cerebrospinal fluid is going to be made in the choroid plexus of the lateral ventricle, the third ventricle, and the fourth ventricle, but majorly in the lateral ventricle. So cerebrospinal fluid is going to be made in this lateral ventricle here. So this is the lateral ventricle. That choroid plexus is the red thing that you see inside of all of the ventricles. So that's where cerebrospinal fluid is going to actually be made and deposited inside of the ventricle. Right, so cerebrospinal fluid moves from this lateral ventricle all the way to this interventricular foramen. Right, so lateral ventricle, right, these two little dog ears, some people see them as. And then you have your interventricular foramen, which transfers cerebrospinal fluid from the left and the right lateral ventricle into the unilateral third ventricle, right? So our lateral ventricle we have one on each side, whereas our third ventricle you only have one structure called the third ventricle. Right, and then from that third ventricle, the cerebrospinal fluid is going to go, right, so from the lateral ventricles to the interventricular foramen to the third ventricle, and then through the cerebral aqueduct, and then as it travels through the cerebral aqueduct, it's going to go into the fourth ventricle. All right, so now that we have that, I just want to get you guys to understand that so we can move forward. Okay. Into the fourth ventricle, and then from the fourth ventricle, it can either go to the spinal cord or it can go to the subarachnoid space and surround the brain, right? Right, so between the pia mater and the arachnoid matter, you have the subarachnoid space, and that's where your cerebrospinal fluid is going to be majorly. But I just want to show you this pathway so we can understand. So when I move to this, right, when I move here, it kind of makes more sense. Right, so we went over the pathways of the ventricular system. Right, now we're seeing some associated brain anatomy, so I'm going to go from the full, right, so from the full brain, right, so this is the brain that we're looking at. Every single structure is here. Now we're going to move on to from the gray matter, right, so the gray matter is the cerebral cortex, to the white matter, which is the, right, cerebrum. The cerebral white matter. And then from there you move on to the bisected brain, which when you have your cerebrum completely removed, right? And then now we can see these structures in between the cerebral hemispheres, right? We don't need to know a lot of these, so I'm going to move on to here. Okay. Actually, I have to remove them because it's removing some structures that we actually do need to know. So just give me a second to remove the structures here. Okay, so okay, remove that. The fornix, let me remove that. Okay. All right, so when looking at the brain, the first structure we're going to see for the first structure that we need to understand is the diencephalon. So the diencephalon is comprised of the thalamus and the hypothalamus. First, that's all you need to know for this class. The hypothalamus and the thalamus comprise the diencephalon. Right, so the diencephalon would be here. Thalamus and the hypothalamus. Right, and connected to the hypothalamus, you have the stalk of the infundibulum, and then you have the pituitary gland. And the reason why I'm showing you that, some structures you don't need to know, but some of the structures on the list are showing two structures but not the connection point. So I want to have you guys be able to understand the connection point so it makes sense when you're looking at it in lab. So you have your diencephalon comprising of your thalamus and your hypothalamus, and then you have your pituitary gland, which is connected to your hypothalamus via this infundibulum. Right? But right when you're looking at your thalamus, right? So if I remove the thalamus, you have two thalamus structures on the right and the left side. So right thalamus, left thalamus. Right? So and we see the thalamus on the left side. Right? So let me just gonna remove the temporal lobe just so. Let me just remove that. All right, so all I'm doing is just removing the cerebrum, right, the left cerebral hemisphere. All right, so that's all I'm doing. And then on that side, we have the other associated structures. Okay, so let me just remove the ones that we don't need to know. All right. So remember, we had a thalamus on this side, and now we're able to see the one on this side, right? So the thalamus is a bilateral structure. You have one on each side. So we remove the thalamus from here. Now we can see, right? Remember, this was the lateral ventricle that we were talking about previously, right? That was your interventricular foramen. You have your third ventricle, and then remember, your third ventricle goes into your cerebral aqueduct, and then your fourth ventricle. But you can't really see that very clearly. If I remove this stuff here, you can. Right, so that's the fourth ventricle. Okay. But okay, so I just want to show you that we had a thalamus here. We removed the thalamus, and now we have this intermediate mass, also known as the interthalamic adhesion. So there's a structure connecting the right and the left thalamus. So this is the left thalamus. We remove the right thalamus, and there's a structure in the middle, in between those two structures, and it's called the interthalamic adhesion. So the reason I want to show you that is because there's a hole, right? There's literally a space inside of this third ventricle. So if I examine the third ventricle, if I inspect it, right, there's literally a space inside of the third ventricle that connects the two structures, the right and the left thalamus. Um, just so you can understand that, I just want to show you that because it makes it very apparent when you're looking at some of these plastinated models where that third ventricle is. Because if you put a pin inside of a space, if you see this interthalamic adhesion, then you know that you're inside of the third ventricle. Then you're looking at the third ventricle. Remember, this third ventricle is just a space, right, that's holding that CSF, that cerebral spinal fluid. So now that we have that, we're going to move on to the other structures. So we saw the thalamus, right? This is the hypothalamus. This is the pituitary gland. And then connecting the hypothalamus to the pituitary gland is that infundibulum stalk. And then now we're going to move on to the brainstem. So the stem of the brain, we have three different structures before we move on to the spinal cord. So we have the midbrain, right? So the midbrain is not a part of the diencephalon. It would be just inferior to the diencephalon. So the midbrain, then you have your pons, and then you have your medulla oblongata. And after your medulla oblongata, you have the spinal cord. So if I examine, right, that's the midbrain. This is the pons. And then from there, we're moving on to the medulla oblongata. Alright, so now that we have that, we're going to move on to some other structures. Okay, now we're going to move on to the brain structure. So we're going to move on to the lobes of the brain. So, right, remember we have our two brain hemispheres. So we have the left hemisphere and the right hemisphere of the um, of the brain. So the left and right cerebral hemispheres, right? And then you have your frontal lobe, right? It's a bilateral structure. You have your parietal lobe. You have your temporal lobe, and then you have your occipital lobe, right? These two would be the occipital lobes. Occipital, occipital, then your temporal, right? And then your frontal lobe. That would be on, well, frontal lobe, and then parietal lobe, parietal lobe. Okay, so in between the right and the left hemispheres, all right, of the cerebrum, right and left cerebral hemispheres, you have the longitudinal fissure. All right, so this fissure in between the right and the left cerebral hemispheres, we have your longitudinal fissure. If I move posterior to the structure under the cerebrum, which is the cerebellum, so the cerebellum is below the cerebrum, we have our right and our left cerebellar hemispheres. Right, so the right and the left cerebellar, so right, left cerebellar hemispheres. Oh my goodness. Right, left cerebellar hemispheres. And in between those two hemispheres, we have a structure in the middle called the vermis. So the vermis separates these two cerebellar hemispheres, and the longitudinal fissure separates these two cerebral hemispheres. Right, and before, remember we were looking at the ventricular system. If I remove these two, if I remove the entire cerebellum, if I remove it, right in front of that cerebellum is the pons. Right, and what structure do we see here? In between the pons and the cerebellum, we see the fourth ventricle. Okay, so now that we have that, we went over the lobes, right? So you have your cerebrum, right? So this whole structure would be your cerebrum, right? This would be the cerebrum, right and left side, cerebrum, and then the ridges, right? The individual little ridges you see here, that's the cerebral cortex. Right, just the ridges. This entire thing is the cerebrum. Cerebral cortex would be these individual ridges, outer layers, right? And that would be known as gray matter. Inside is known as white matter. Now that we have that, let me make sure that we went over all the structures. Okay, so now we have that. I'm gonna move on to the dural venous sinuses, and then we're gonna move on to the circle of Willis. So, matter of fact, let me just do the. I'm gonna show you guys the meninges first, just so we understand and it makes sense. We move on to the dural venous sinuses, so I'm gonna show you the meninges first. Right, so this is a part of your pre-lab. So I just want to show you this because Anatomy TV doesn't really show the dural venous sinuses very well or even at all. So I'm gonna go into show you the not the dural venous sinuses, the meninges. Sorry, the meninges. Right. So your meninges. So you have three layers of meninge. You have your dura, your arachnoid, and your pia mater. So the deepest layer of the dura mater is the pia mater, and the pia mater is directly adhered to the brain, right? And then in between the pia mater and the arachnoid mater, you have the subarachnoid space. So if I'm looking at this here, So this is the pia mater, this is the arachnoid mater, and in between the arachnoid and the pia mater, you have the subarachnoid space, and that's where your cerebrospinal fluid is going to be traveling. And then you have this thick dura mater here, right? So if we look at the if we look at the this structure here, we have we have a couple of different structures that we can actually see from this picture. So remember, we the dura mater is going to be that thick layer. It's going to be that tough layer, and then you're going to have that spider layer directly over the pia mater. So you're going to have that spider-looking layer, which is called the arachnoid mater. It's going to look like a bunch of webs, and then the pia mater is going to be directly adhered to the brain, right? So the cerebrum, you're going to see that you can't remove the pia mater because it's directly adhered to the surface of the brain. But you can remove the dura mater and you can remove the pia mater, not the dura mater and the arachnoid mater. The pia mater you can't remove, but the dura and the arachnoid you can. So remember, this would be the pia mater, and then you have your subarachnoid space, right? That web-like space, subarachnoid space where the CFS is going to be traveling, right? Directly under that web-like space, which is the arachnoid mater. So arachnoid means spider, and it's going to be like that web-like structure you see on top of the pia mater, and then you have your subarachnoid space, which is going to be under the arachnoid mater, and then the dura mater, you have um, that tough layer on top of those two um, meninges we just talked about. Right, and one thing that's very important with the dura mater, it's going to hold the sinuses. So inside of the dura mater, you're going to see the dural venous sinuses. So right when we're looking at some of these meninges, right, we have the this first one, the falx cerebri, and then you have the falx cerebelli, right? So in between the two hemispheres, the two cerebral hemispheres, which is cerebri means cerebral. So in between the two cerebral hemispheres, you're going to have the falx cerebri. In between the two cerebellar hemispheres, right? This is going to be superficial to the vermis. You're going to have the falx cerebelli over the actual um, over the cerebellum, right? In between the cerebellum and the cerebrum, you're going to have the tentorium cerebelli. It's been cut here, so you can't see it very well, right? So remember, this whole thing would be covered, right? Because your cerebellum would be here, and this dura mater would be covering the cerebellum as a separation between the cerebrum and the cerebellum. Right, so you have your falx cerebri, your tentorium cerebelli, which is that dura mater in between your cerebellum and then between your cerebrum. Right, and then separating your cerebral hemispheres, you have your falx cerebri, and separating your cerebellar hemispheres, you have your falx cerebelli. Right, so literally inside of this dura mater, you're going to find your dural venous sinuses. Your dural venous sinuses. Right, so inside of the dura mater, you're going to find those sinuses. So now that we have that, I'm going to move on to the actual structures. So remember, your pia mater is going to be directly adhered to the surface of the brain. Right, your arachnoid mater is going to be above that layer, and in between your arachnoid mater and your pia mater, you're going to find that subarachnoid space. That is where CFS is going to be traveling through. That's where you're going to find CSF. Right, there's really nothing in between the arachnoid, the arachnoid matter, and the dura mater. There's not really anything you need to worry about. And then you have your dura mater on top of your arachnoid mater. Right, arachnoid spider-like is going to look web-like, and then dura mater is going to be very tough, right? And that's where you're going to find your durovenous sinuses. So if I move on to the durovenous sinuses, right? So I'm not going to worry about the arterial structures yet because that's when we get to the circle of Willis. So I'm going to remove the arterial structures. Right, remember our durovenous sinuses. This is the venous system, right? So veins going back to the heart, arteries away. All right, so when we're looking at durovenous sinuses, remember you're going to have your falx cerebri, right? Right, our falx cerebri is going to be here. It's going to be coming from the crista galli and going all the way to, right, the posterior aspect, right? It's going to attach somewhere in the occipital lobe. So, right, all the way, right, around like this. And this is going to be your superior sagittal sinus is going to be contained within your falx cerebri, or your falx cerebri is going to contain your superior sagittal sinus. Remember, that's dura mater. Right, so inside of the falx cerebri, you're going to have your superior sagittal sinus inside of your falx cerebri. Right, remember this is dura mater. Right, and then from the superior sagittal sinus, we move on to the confluence of sinuses. Right, so that's this structure right here, right? This is the confluence of sinuses. So the confluence of sinuses is, right, venous blood is coming from the superior sagittal sinus, all these other veins, right, on the brain, and they're all draining into the confluence of sinuses, which is here in the occipital occipital region of the brain, or the cranium more so. Right, and then from the confluence of sinuses, we travel into the transverse sinuses. So there's two transverse sinuses, the right and the right and the left. So right and the left. And remember, you're going to want to orient yourself on right and left with the brain, because depending on if I'm looking at it like this, right, this is going to be right and left. If I'm looking at it like this, ooh, let me slow that down. So if I'm looking at it like this is going to be right, this is going to be left. If it's turned this way, right, this is going to be right, this is going to be left. Now if I flip it around, turn it all the way around, and then you're not going to know how to orient yourself. Remember, this is going to be right, this is going to be left. If I'm looking at it inferiorly and it's turned, right, this is going to be left, this is going to be right. So remember, depending on how you're looking at it, this is how it would be situated inside of your brain, looking at it this way. But if it's turned around, right, it's going to be flipped, right? This is going to be right, this is going to be left. So make sure you know, depending on how you're looking at it, it's going to look different. Different different lobes are going to be in different areas. It's going to be flipped, inverted. So make sure you know how you're looking at it and which direction is which, or which side is which more so. So remember, we were talking about the superior sagittal sinus, which drains into the confluence of sinuses, and the confluence of sinus drains into the right and the left transverse sinus. Right and the left transverse sinus. And then from there, from our right and our left transverse sinus, we go into the sigmoid sinus. Right, so sigmoid sinus. So right and left transverse sinus go into the sigmoid sinus. And then from our sigmoid sinus, we go into the internal jugular vein. That's what this is here. But also draining into the internal jugular vein is the cavernous sinus. Okay, so let me just make sure I got a good. Okay. So I wouldn't worry about the direct pathway because there's some structures you guys don't need to know, but just know the cavernous sinus is draining into the internal jugular vein as well. Okay, so I think that's the best way to look at it. Yeah, perfect. Okay, inspect. Right. So remember, this is how it is looking. So we have our superior sagittal sinus, which drains into the confluence of sinuses. The confluence of sinus moves on to the transverse, left and right. And then from our transverse sinus, we move into our sigmoid sinus. Sigmoid sinus, right? And then from there, we move into the jugular vein, right? But also, we have to remember that we have a cavernous sinus that's also draining into the internal jugular vein. All right, so now that we have that, remember, so our cavernous sinus and our sigmoid sinus are both draining into the internal jugular vein. All right, so now that we have that, that's everything for our durovenous sinuses. So internal jugular vein here. Right, this is our cavernous sinus, right, draining into our internal jugular vein. Now we're going to move on to the last thing, the circle of Willis. All right, so this gets a little bit complicated, so I'm going to slow it down. Make sure that we're looking at the right. Yep, okay. I'm just going to do it like this. So I'm going to remove the durovenous sinuses and the arterial system, which is the circle of Willis. So let me remove the durovenous sinuses, veins. Okay. All right, so remember that one's a venous system and then one's an arterial system. Okay, so the way we look at the circle of Willis, so this is the circle of Willis. All right, the way I start is looking at where it's starting. So we're starting at our vertebral arteries. So this is our left vertebral artery. Sorry. So looking at it from the back, this is the right. Looking at it from the front, this is the left. All right, so this would be the left. This would be the right. So right, right, and then this would be the left. So this is how you'd be looking at it. So this is how your brain is situated in your head, right? Directly how you're looking at it, and then this would be if somebody was looking at you. So, so if you were looking at somebody, right, this would be right, this would be left. Now that we have that down, we have our two right and our left vertebral arteries, which drain in to form the basilar. So, two vertebral arteries converge to form the basilar artery. From our basilar artery, we travel on to form our posterior cerebral artery. And there's a right one and there's a left one. Right, so especially when we're looking at our donors, there's going to also be cerebellar arteries. So don't worry about the cerebellar arteries, but you're going to see them before you see your cerebral arteries. So your cerebellar arteries, we're not pinning that. Don't get that confused for your um, posterior cerebral. So posterior cerebral left, posterior cerebral right. Make sure that you're not getting your posterior cerebral left and right mixed with these two arteries you don't need to know. So we went from vertebral, right vertebral artery to your left vertebral artery, converge to form the basilar, and then your basilar artery splits into your right and your left posterior cerebral artery. Right, and then from there, you're going to move into your posterior communicating artery. But what I want to do is I want to remove portions of the internal carotid. Matter of fact, let me put that big. Yeah, okay, so. Right, so this is your internal carotid, but we're going to show that later. So we went from to vertebral to basilar. We're forgetting about those cerebellar arteries, which are before the posterior cerebral arteries. So posterior cerebral, left and right. And then from our posterior cerebral, we move into our posterior communicating. So posterior communicating artery, there's a right one, and then there's a left one as well. Right, so vertebral, right and left to basilar, and then we go to from our basilar to our right and our left posterior communicating, posterior cerebral to our posterior communicating. So vertebral, basilar, posterior cerebral to posterior communicating. And then from our posterior communicating, we go to our internal carotid artery. Right? These are both our internal carotids. Right? And then our internal carotid, you can see it transform into our middle cerebral, left and right. And then our middle, see these are our middle cerebral arteries, so middle cerebral. And then also coming from our internal carotid, we see the anterior cerebral arteries, right and left. And connecting the anterior cerebral arteries are the anterior communicating arteries. So remember, we have two posterior communicating arteries, and we have one anterior communicating artery. Okay, so I just want to inspect that. So remember, so blood is coming away from the heart and to these arteries. So through the vertebral and through the internal carotid, it's traveling from the posterior, right, to the anterior. Right, so you see blood coming in the vertebral arteries, and blood is also coming in the internal carotid, and this is how blood supply is coming from the heart to the brain. So again, we go from our right and our left vertebral arteries. Our vertebral arteries converge to form our basilar artery, and then our basilar artery diverges to form the right and the left posterior cerebral artery. So right and left posterior cerebral. All right, so basilar to right and left posterior cerebral artery, and then we move to our posterior communicating artery, right and left. Right, this is our internal carotid artery, so more blood is flowing into the circle of Willis via the internal carotid artery, and then internal carotid moves into the middle cerebral artery, right and left. And then also blood is flowing into the anterior cerebral artery. And in between the two anterior cerebral arteries, right and left, we have the anterior communicating artery. All right, and I want to remove one of the hemispheres just so we can see the anterior a little bit better. Okay, so I'm going to remove one of these hemispheres just so we can see a little bit better. So remember, I just want to highlight all the structures one more time, and then that'll be it. So internal carotid, vertebral artery, blood is coming in from these two structures. All right, we have our basilar, we have our right and left posterior cerebral, right? And then we're going to go from our right and left posterior cerebral to our right and left posterior communicating arteries. Then from there, we're at the internal carotid, and then we also see our middle cerebral arteries and also our anterior cerebral arteries. And connecting our anterior cerebral arteries are the singular anterior communicating artery. And I just wanted to show you, because you can't really see the anterior communicating artery very well without the brain being bisected. So anterior cerebral artery. See how it's applying the anterior aspect of the brain. Right? The frontal lobe, anterior cerebral artery. And that is it. I hope this was helpful, guys. Good luck. And have a great rest of your week, guys.